My name is Ivan Puparev, and I work for Advanced Technology and Projects Group at Google. The hand is the ultimate input device. It's extremely precise, it's extremely fast, and it's very natural for us to use it, right? Capturing the possibilities of human hand was one of my passions. How can we take this incredible capability, finesse of human actions, or finesse of using our hand, but apply it to the virtual world? We use radio frequency spectrum, which is radars, to track human hand. The radars has been used for many different things, to track cars, big objects, satellites and planes. We're using them to track micro motions, twitches of human hands, and then use that to interact with wearables and Internet of Things and other computing devices.
Our team is focused on taking radar hardware and turning it into a gesture sensor. Radar is a technology which transmits a radio wave towards a target, and then the receiver of the radar intercepts the reflected energy from that target. The reason why we're able to interpret so much from this one radar signal is because of the full gesture recognition pipeline that we've built. The various stages of this pipeline are designed to extract specific gesture information from this one radar signal that we receive at a high frame rate.
From these strange foreign range Doppler signals, we're actually interpreting human intent.
Radar has some unique properties when compared to cameras, for example. It has very high positional accuracy, which means that you can sense the tiniest motions.
We arrived at this idea of virtual tools because we recognized that there's certain archetypes of controls, like a volume knob or a physical slider, a volume slider. Imagine a button between your thumb and your index finger, and the button's not there, but pressing this is a very clear action, and there's a natural physical haptic feedback that occurs as you perform that action. The hand can both embody that virtual tool, and it can also be acting on that virtual tool at the same time. So if we can recognize that action, we have an interesting direction for interacting with technology.
So when we started this project, me and my team, we looked at the project idea and we thought, are we going to make it or not? We don't know, but we have to do it. Because unless you do it, you don't know.
And what I think I'm most proud of about our project is we have pushed the processing power of the electronics itself further out to do the sensing part for us.
The radar has properties which no other technology has. It can work through materials, can embed it into the objects. It allows to track really precise motions. And what is most exciting about it is that you can shrink the entire radar and put it in a tiny chip. That's what makes this approach so promising. It's extremely reliable. There's nothing to break. There's no moving parts. There's no lenses. There's nothing. It's just a piece of sand on your board.
Now we're at a point where we have the hardware where we can sense these interactions and we can put them to work. We can explore how well they work and how well they might work in products.
Blows your mind usually when you see things people do. And that's what I'm really looking forward to. I'm really looking forward to releasing this to the development community, and I really want them to be excited and motivated to do something cool with it, right?